Section 10.5 is all about exponential functions. It's really just an introduction to the basics of exponential functions. We haven't talked about these yet this year, but an exponential function is just a function that can be described by an equation of the form y equals something to the x power. I'm just putting a 2 so that you can see it, but it really can be anything raised to the x power. A lot of the generic one would be like a to the x power. So when where a is greater than 0 and a cannot equal 1. So if a equals 1 and you're raising it to an exponent, that would be y equals 1 every single time, which would just give you a horizontal line. So a can't equal 1 in order for it to actually be a true exponential function. So if we want to graph, your most basic way to graph an exponential function is to make a table of values, just like with everything else. When we're starting and we're doing our most basic type of graphing, we always resort to a table of values to show you where it comes from. And so you just need to put this in your calculator. I'll show you what most of your calculators look like. So we're doing y equals 3 to the x power. So in this case, we're doing 3 to the negative second power, 3 to the negative first power, 3 to the 0 power, 3 to the first power, 3 to the second power. Now these down at the bottom, you could do without a calculator. 3 squared is, of course, 9. 3 to the first is 3. 3 to the 0, if you remember our exponent chapter, anything raised to the 0 power is always 1. 3 to the negative first. Now you really don't need a calculator at all here if you look at the pattern. We're dividing by 3, dividing by 3. If I divide 1 by 3, I get 1/3. And if I divide 1/3 by 3, I get 1/9. You can also remember, go back to when we did negative exponents, that's really equal to 1/3 squared. Remember, the negative becomes the 1 on the top, and the 2 stays as your exponent on the bottom. So 1/3 squared would be 1/9. So there's lots of ways you can do this without a calculator, using several of the things that we've learned this year. Once you have your table of values, then you want to plot the values. We've got, I'm going to start with 0, 1, 1, 3, and 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. These other guys, negative 1, 1/3, you just kind of eyeball where it is, and negative 2, 1/9 is going to be right there. So this is what it would look like. Kind of looks like the incline of a roller coaster. We're going up. Okay, so there's your exponential function. Then it says state the y-intercept. So the y-intercept is the place where it crosses the y-axis, which is 0, 1. 0, 1. You can see it here. You can also see it here in the table, 0, 1. Okay, that's going to be your y-intercept. We'll do the same thing for this guy. This one's a little stranger, a little more difficult. So we're doing y equals 1/4 to the x power. So 1/4 to the 0 power, 1/4 to the first power, 1/4 to the second power. Those should be pretty easy. 1/4 to the negative first, 1/4 to the negative second. And technically you need parentheses around these so that it's understood the way it's supposed to be understood. So 1/4 to the second power is, of course, 1/4 times 1/4, which is 1/16. 1/4 to the first power is 1/4. Anything to the 0 power is 1. Now if we look at the pattern, this one's not quite as obvious, but we're actually multiplying by 4, multiplying by 4, multiplying by 4, multiplying by 4. Let's do the exponential way. Remember when we did exponent rules, we did the negative to the top and the negative to the bottom. I'm going to do the work right here. So we get 1 to the negative second power and 4 to the negative second. If we do should it stay or should it go, then that means both of these go. So we get 1 to the second on the bottom and 4 to the second on the top, which gives us 16. So you can find the pattern, but in this case the pattern might be a little more challenging. You could also distribute your exponent, simplify it to get 16. This one works the same way. We get 1/4 to the negative second, or negative first, I'm sorry. So we get 1 to the first and 4 to the first, which is, of course, 4. So that's where we're getting these guys here. Then we go to graph it. 0, 1, 1, 1/4 is about here. 2, 1/16 is going to be real close. Negative 1, 1, 2, 3, 4. Negative 2, and then the 16 is going to be way off the graph, so somewhere up here. Okay, which we don't really need that. We're going to turn it a little bit so I can get a good, woo! Okay, so there's my exponential function there. Identifying exponential behavior. Oh, we need to do our y-intercept. The y-intercept is, again, 0, 1. You can see it where it crosses the y-axis right here. So that's also 0, 1. One way to determine if a set of data displays exponential behavior is to graph the data and then determine the shape of the graph, which is what we just did. So if it rises quickly or falls quickly, and what's going to happen here is it's going to keep getting very, 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 very close to that line, but it's never actually going to cross over that line. There's an imaginary line there that it's never going to hit. It's like a wall. Another way to determine if a set of data displays exponential behavior is to look for a pattern in the set of data. To determine if a set of data is exponential, we should look for a common factor. And so a common factor is something that it keeps getting multiplied by or divided by. So I showed you the common factors here. We multiplied by 3, multiplied by 3, multiplied by 3, multiplied by 3. Here we divided by 4, divided by 4, divided by 4, divided by 4. So whether it's growing or getting bigger or getting smaller depends on what the pattern is, of course. So determine whether the data in each table displays an exponential behavior. Explain why or why not. So we're going 0, 2, 4, 6, 8, 10. So we got a pattern going up here. What's the pattern here? Oops. Can't see that, can you? All right. So what's the pattern going on here? What do we see happening? Well, we're going to 32, then to 16, then to 8, then to 4, then to 2. The common factor, well, what we're actually doing is dividing by 2. But the common factor has to be something that it's being multiplied by. Multiplied by something. And they all have to be multiplied by that same value. So we're dividing by 2, but that means the common factor is in fact 1/2 because we're multiplying by 1/2, multiplied by 1/2, multiplied by 1/2, multiplied by 1/2. So it is exponential. The common factor is 1/2. So we have to state what it's being multiplied by. If you wrote the common factor as 2, that's actually incorrect. So you need to be careful. We're multiplying by 1/2, which tells us it's getting smaller. If you say the common factor is 2, then that would tell us that it's getting bigger. So you have to be careful that you write what you're being multiplied by. Let's look at the pattern here. We do have the pattern going on in the x's, going up by 1. And let's look here. We've got 5 to 10, 10 to 15, 15 to 20. There's a pattern here, which may throw you. But in this case, we're multiplying by 2. But in this case, we're not multiplying by 2, and we're not multiplying by 2 here. So in this case, we would actually be multiplying by 1/2. And then here we'd be multiplying by 1 1/3. How do you figure that out? You do 20 divided by 15 is 1 1/3. 15 divided by 10 is 1 1/2. So we can tell that they don't have a common factor. They all are, of course, being added. 5 is being added each time. But that doesn't make it exponential. That makes it linear. So if you're adding 5, adding 5, adding 5, that actually tells us it's a linear function if there's a common difference. There's a common difference. You're adding the same thing every time versus multiplying. So this is not exponential. Instead, it's a linear function. There's no common factor, no CF. Okay? And if you're going to claim that it's not exponential, you need to actually show a little bit here what the factors are, or something here, before you say that it's not a common factor. Okay? So that's pretty much it. That's just our introduction to exponentials. Your homework, or rather your classwork, which you should probably be able to get done here, is on the back. Now, you don't have to rip it out if you don't want to, but there is one difference here that we didn't do on the front, and that is that we're throwing an exponent in and then adding 1, or adding 2, or adding 3. So let's go back actually and talk about how you would do that. If this were 3 to the x plus 1, you would just add 1 to each of these answers. Okay, so it would be 1 1/9, 1 1/3, 2, 4, 10. Okay, getting back here. So just follow what it says. So here you would raise it to the exponent, then subtract 1, and whatever you get there, then you multiply it by 2. So I did the most basic ones, but you're really just, following the order of operations. So when you are showing your work here, you should have some work to the right. Oops. You should have some work over here to the right of exactly what you did. Like one step, or maybe, yeah, one step's probably good enough. And then you can still stick with the same values, -2, -1, 0, 1, and 2 for those. It does say state the y-intercept on that one. Up here, it says estimate the value of the given expression. This is a piece that we didn't do. So, and it says use a calculator to confirm the value. So this says 1/10 to the -0.5 and 3 to the 1.9. So let me show you what I mean here. We've got, what if I said 3 to the 1.7? Okay, so this is 3 to each of these x powers, so I find where 1.7 would be on the graph. 1.7 would be about here, and I go up from there, and I kind of guess what that value would be right there. So that would be 1, 2, 3, 4, 5, 6. It's about 6. So here's my estimate. 3 to the 1.7 should equal 6. That's a question. Not sure. Now I can put that in my calculator. It says use your calculator to estimate it. So this is how you do it. 3, and then you push your caret button, raise it to the 1.7, and I got 6.47. So you want to actually write your value here. So you use your graph to guess it, and then plug it into your calculator to see how far off you were. So that's what you would be doing there. If it says to the -0.5, like the first one says, I'd find where -0.5 would be, and I'd go up from there. So 3 to the -0.5, I would guess would be about 0.6. That's my guess. And if I put that in my calculator, again, 3, raise it to the -0.5, gives me 0.57. I was pretty close on that one. Okay, so give me your estimate based on your graph, and then plug it into your calculator and find the exact amount. This is the exact. This is the graph. So that's what you're going to be doing for those other pieces. The rest is exactly the same. You should have tables on every single one of these, just like this guy with the -1, or -2, -1, 0, 1, and 2. And then you got some word problems, and it gives you some hints here. So you're going to be working on this for the rest of class. If you finish it, you can give it to the sub. If you don't finish it, then you'll need to bring it in tomorrow.